Hello.
Hello, everybody.
Hello, everybody. Two of you. Anyway, we will start with our webinar. Today's is the 14th number.
Yeah.
So chy.stat news with number 14. And hello from my side, from Honza and from Adrian.
Hello. Let's talk about the news in episode 14.
Yeah, true, because it's quite hard topic. Because it's topic of the process capability.
And on our side, you too.
So I will share screen.
Well,
sorry, yeah.
About talking.
And I will say something about agenda. So today will be the main two topics, one from Crustallus, one from graphic. In Crustallus, we will talk about new algorithm for capability calculation. We will show new graphic empirical CDF and new graphic CP/CPK, which is the display the intervals of or the confidence intervals for the CP/CPK results.
Yes.
And the second part of the webinar will be about the graphics, general graphics. One thing is the new zooming with mouse wheel. Second one is the improved graphics loading in details. The last one will be the configuration of the default X offset in the curve.
Yeah, exactly.
So
we can start. Okay. Well, we start with a brief history of the capability indexes. Yeah. For first, CP and CPK are useful characteristic for comparing processes. Yeah. Okay. What we talk about CP? CP compares the range of the specification. It's mean tolerances, for example, to the range of the data. I think values, measuring values. Attention, CP doesn't consider the centering of the process. CPK, next KPI index, represents the distance of the center of the process. That means mean or some characteristic of means to the nearest specification limits. Yeah, this is different indexes. Yeah. In chy.stat, we prepare different tools to analyze the indexes. For example, like on the slide, you can see a couple graphics. For example, histogram, value plot, and a new plot, empirical distribution function. Yeah. We spoke about this ADC plot later. And the main graphics in reports we show later about graphic of CP and CPK.
Yes.
Okay.
But in this we just try to explain what the CP/CPK is, the basics. That mean that's your mobile. Sorry. That mean the CP if the process is inside and how inside. Yeah. CPK if the process is above tolerances.
Yeah, it's a joke.
It's about the joke with the car. The car fits in the garage or not.
Depend on driver.
If it fits in the garage where in the garage the car is.
Inside of the garage or center in garage.
You can see it in the histogram. You can see it in the value chart. You can see it in the empirical distribution function. Also here, if is it about the whole tolerances and where is it
exactly.
above the lower or higher tolerance.
Yeah,
just the basics. Yeah. So we can. Oh, Ignat, maybe.
Yeah, sorry. Maybe I have a problem with the connection, but I can see you're sharing.
You can't see.
It's a problem just with me, or?
I can see it. I can see the screen.
I will try again. So wait, share.
Yeah,
so what about now? Is it? Can you see it?
It's just a white screen, and maybe I have a problem with the connection, with the network. I don't know. Okay, thank you.
Oh, that's bad.
Yeah. Because I wanted to see, but
what to do? Could you try to? I don't know. Maybe unconnect or
yes.
Connection to the. Yeah. We can wait.
We can wait.
Okay. Yeah. Thank you.
Right.
It's a pity.
Mm-hmm.
Počkáme, kým sa prihlási znova. See our desktop.
No, not working.
It's still white, yeah.
Yeah. I know I'm not. I'm out of office, and I'm in another city, not in Brasov. I'm in Bucharest, and maybe it's a problem with the network.
Yes. What to do? I don't know what to do because it's.
Maybe if this training is recorded, maybe I can.
It will be. It is recorded, so
okay.
I just listen. So that you can see the visualization on the YouTube afterwards. If is it okay for you?
Yeah. Thank you.
Maybe from our side, I'm not sure. I don't know. But Martina said that she can see.
I can see too.
Daniel too.
Yeah. Okay. We will go through.
Okay. Thank you, and sorry for interruption.
Oh, don't worry. Okay. So another slide will be about the differences in our new capability calculation. I will start with what stays. What is not changing is that we use CP/CPK indexes.
Yeah, absolutely.
Indices. That's
and evaluation too. That means you still using a ratio of tolerances and process.
Yeah. Okay. What stays is also that the higher, the better assumption that the process will be good. That stays. And if the CP/CPK is high, that means the better, the safer within the tolerances. And better, the higher, that means that we don't have to care about the process because it's enough good.
Yeah.
And we need to, let's say, better to see a needle in the haystack than the better.
And we have time for main problems.
Yeah. So that stays. But what goes?
What goes? We cancel decision tree strategy. Yeah. Similarly, we do not use the division into process model. like A, B, C, and D. You know it, I think. And we also do not use mean and variation testing. We using a new algorithms there. We will talk about later about algorithm.
So this means that we don't use strategies because there are too many strategies, and one strategy looks in the process with some look and the different look, and the same, let's say, the same process with two different strategies was two different evaluations, and sometimes it's doesn't meet the
cross of the results.
It doesn't mean that we can't compare them. But it's the same process. The type of the processes. So that's why we cancel some strategies.
Three strategies.
So what is changing is that, and let's say how well we know the processes. Also, the better consistency in the monotony. That's mean in the same calculation of the indexes through white will be the higher. We can compare them. That's mean the higher CP/CPK is really the better.
We focus on how well we know, and we will not be distributed by lower reliance on unofficial evidence. And necessary, if we learning from the past, we can use our algorithms for the small sample size.
Yes, the vision that if we can learn was the best process for us, and we can learn from it. Also with new data, small size of the data, and we can say if is it, or we can alarm if is it
exactly
else than from the past.
Exactly.
It's our vision that we would like to have it in the future like that we can learn and have information from the last performance.
And we look at the process
as
a collect of noises. And these noises we try to describe each cluster of noises by normal distribution. That's a main idea of that. The result is the direction of the normal distributions in the results. The principle of the in a principle is the Chinese restaurants algorithm there.
That means that we don't use decision tree strategy, but we look at the process like in general, but try to see some kind of noises. And if the noise is not good enough for one normal distribution, we add another. So exactly. The result is the
collect of
normal distributions.
Exactly. It's a main principle of our algorithm. Well, we can continue. Next
is the graphic. Anyway, is the empirical CDF graphical?
Yes. So that's mean. What does it mean? Empirical distribution function. That's mean we can show you or
probability net.
Exactly. It's the curve. And dot means each of the values on our data.
And also we can see the probability of next sample size. If the next values will be with some kind of probability above the higher or lower tolerances. And we can compare between each processes to see which process will be probable with more probability above the tolerances and which less.
Exactly. Like an example on our presentation. We have three different type of beers because beers is very good stuff.
Yeah, it's in
for
our
compare.
It's in our demo.
Yeah, it's from our demo. It's only joke.
Yeah,
maybe not good.
Okay, so this is the new graphic and
Yeah,
another new
okay.
graphic with that.
The last thing on ADC
Okay.
was
Sorry.
the light color. This is a confidential interval of model distribution. Yeah, you can see confidential interval.
I mean here.
Yeah, in light color. Okay, that's all. Now I'm finished.
Another new graphic is the graphic that shows confidence intervals and estimate result of the CP and CPK. We have fixed scale from 0.7 to 1.7 with 1, which is the goal for the estimate result.
Yeah,
That's mean that you are in the tolerances.
Yeah, exactly. That's mean car is in a garage.
Car is
both
in
in
the
and
garage.
both.
Yeah. And we have also visualization if is it better or worse.
Yes.
Much better means with the arrow, arrow, and if is it much worse, it's left arrow. Yeah. Because if is it much better, we don't care what is estimate result and confidence interval because it's not interesting. Yeah. But we have another colors. That's mean you said like
I have some notes for that. We prepared 3 types of alarms here. Yeah, or you can expect 4 different colors that interpret the significance of the alarms.
Yeah, maybe I will explain the green one.
Okay.
So the green one, if is everything okay, we can say, and we can see what? We can see confidence intervals, the low interval and the high interval. And also we can see estimate result of CP or CPK.
Yeah.
And if we are above 1, we are green.
Yeah,
and we can see
we are cool. Yeah.
But if we are yellow, that's mean
it's maybe light warning. Maybe light warning. Okay, we have trouble with the lower limit of confidential interval. Yeah. But point estimate is still above limit.
Above the goal, which is 1.
Yes, thank you. Exactly. It's yellow alarm.
Yeah. So probably we will be good, but there is the chance that maybe we could be above the goal.
That means look on the process, maybe something wrong.
It's the first.
It's
warning.
Yeah, light warning.
Second one is the green, orange.
Sorry, Orange warning. Name, for example, heavy warnings. Still warning. We have 2 problems here. First is confidential interval over. Confidential interval is
above
before
above the goal.
Yeah, above the goal. Estimate point is the same above the goal, but the lower limit is
higher.
Is still higher.
Higher interval is above the goal.
Yeah, exactly.
That one.
Yeah.
So there is the chance that the process will be good, but I think we should do something with it.
We need here much better technical interpreter of what's happening in process. Yeah? We still only interpret now statistical number, not technical process. Yeah. Okay.
And the last one is red.
Right.
Both
it's
intervals
pure
and also estimate results are
we have trouble here
above the goal or under the goal.
Yeah,
of course, under the 1. So we have to do something.
Yeah,
or maybe not.
maybe not.
Also technical.
Change the tolerances. No, it's a joke. We have here trouble, and we need to know. We need to do something with the processes. Depend on our knowledge, technical knowledge. The same like in a highly alarm. Okay, thank you.
We can also show you where you can
set this
graphic in the system settings, in the graphics, and here is the part of the graphic called characteristic overview. And in that graphic we can choose in the content type the capability index chart. That's how it's called in chy.stat. And there you can choose between some algorithms, because you can have different but the same principles of the algorithm CP/CPK, but different, let's say, a minimum of the values and that kind of things. And you can choose between CP/CPK. Yeah. Okay, so that's the topic of CP/CPK. Maybe I will sum up. We canceled strategy 3.3.
Yeah.
We focus on the we focus on sum of the normal distribution when we calculate it. We focus on the actual alarms, which in the future we will compare with the last performance of the process. So we focus on the actual and future alarms in the processes, not go month by month what happened and after that what. You can do nothing.
Yeah, exactly. That means we still can values, small sample size values to our module of algorithm.
To say to show alarms with the 5 new values and
for example,
alarm because we are above the, for example, confidence intervals.
Yeah.
Okay, so another topic is the graphics. The new one thing is that we can zoom with the mouse wheel. That's like in Google Maps.
Yeah.
Sorry, that's here. Show you.
It's very useful in curve.
It could be useful in curve, yeah, of course. I could. Yeah, there is the
two possibilities.
Zoom tool, and you can choose between box select, mouse wheel. Mouse wheel is when I move with mouse wheel, I can go
throughout.
Curve. I can zoom in.
Zoom in
and zoom out. The box select is like that. It works also in, let's say, value chart, histogram, and so on. In these graphics, it works like zoom in x-axis, but in curve, it works like with the x and epsilon axis, so 2 axis. Great. Another new thing is that we improve graphic loading in the details. That means that we don't have to wait till the whole graphics will be loaded or by data, say loaded. But it will load when we click on the detail, and the graphics will load one per one.
We see something happen.
Yeah, let's say I will click here
in background,
and there, one loaded, second loaded, third loaded, and we are waiting for histogram till it will be loaded. Well, I hope sometime.
Sometime.
Yeah, but you can see, you can work with it. You can analyze the process. But in the past, we waited a long time. But now maybe I don't know why. Doesn't matter. And the last topic is curves, configuration of default X offset. So we can choose between important points on the curve and set which will be the default reference point for initial load of the graphic.
Yeah, you can choose an important point like a default point in a curve.
Okay.
When you first time to load.
And it looks like if I click on the graphic, where I set the default offset, you can see here that there is the default offset, and the graphics are already offset on
this point.
That point. So I don't have to click here offset X, offset Y, offset X, and choose which point I would like to offset the curves. So
it's useful for analyze. Yeah. I think
great. Yeah, it's the end of the webinar. We go through all topics we wanted to show you today.
Diribet, we are Diribet. Diribet, we are Diribet. Diribet, we are Diribet, we are Diribet.